high level. Um, yep. On high level, if you see, we discussed data warehousing. The primary purpose of Snowflake is data warehouse, right? So we had a quick recap of our overview on the data warehousing concepts. So basically, since we'll be maintaining history in data warehouse, and we are going to integrate or combine data from multiple uh, OLTP systems or databases. That is, from multiple applications, we'll try to combine data and store it in data warehouse, right? So the data volumes will be high. So that's when like we'll face issues. Basically, for OLTP systems, since we maintain only current data and data volumes will be less, so we may not face any performance issues as such with relational databases. But with respect to data warehouse, since the data volumes are more, we'll face issues, right? And that's when like our relational databases may not be able to serve the purpose, right? So let's quickly like see. Today we'll discuss like what is one, why you have to go with Snowflake. We have relational databases. Now like you would have got some understanding of why, I mean, we have to go with Snowflake instead of relational database. Relational database, you would be aware, right, what it is. Yeah, that is we'll store data in rows and columns, and then like if you take Oracle, SQL Server, MySQL, PostgreSQL, they are all relational databases. Okay, so these are all relational databases. Here, if you take relational database architecture, it is shared disk architecture. Okay, we call this shared disk architecture. The reason is you are going to store all the data in one server, right? Shared. It is it. I mean, you are going to share all your data in one hard disk, that is disk, right? And then that is used by multiple users. Okay, here the major drawback with this relational database is like we are going to like that is wherever you install your that particular database management system, that is DBMS, say Oracle, SQL Server, that particular software, right? So wherever you install that in a machine, like it is single machine, like single server. So say if we have to run a query or insert some data, whatever it is, right? So it would require all compute resources. So all the data will be stored in hard disk in that particular server, and then you will use RAM, processor, and then memory in order to run your queries, right? So here you can think of like for one mission, like how much how we can that is if we have to increase the capacity of that particular server, right? uh, Say right now you're using like 500 TB or something like that, 1 petabyte of storage hard disk, or 1 TB of hard disk. So how much extent you'll be able to keep on adding your storage, that is hard disk, and then processor also. So hard disk, so maybe you'll get chance to add, but I mean there also we have a limit. Beyond certain limit, you'll not be able to extend storage capacity also, that is hard disk, right? Let me think. I think still people are here. I mean, the major drawback with relational databases, for small volume of data, it will serve, and lesser number of users. How like each and every user who will connect to that server and try to access the data, right? Like there is some limit in the sense every user, if he's trying to run a query or insert some data into the database, so he requires like compute resources, that is processor, RAM, memory, all these things, right? So within, so if it exceeds the capacity of this server, that is say you have like high capacity of I mean processor that you are using, and then like say you are using even a huge RAM, but how many users it will be able to serve, right? That is the thing. So there is a limit or with respect to increasing the capacity of one server, right? So that's when like if you take big data, right? Big data is right now it is all digital and internet of things. So the data is growing very fast. Here if you take big data, it is not just volume. Okay, it's not just volume of data, that is size of data. It refers to um, volume, velocity, and variety. That is, volume is one thing, and after that, the speed of changing the data. Okay, the data is changing very fast. Okay, that is one thing, and variety of data. Earlier, it is all like used to come in structured way. That is columns and rows. You'll get CSV files, Excel files that way, or it was all structured data. Now, if you take images, if you see even WhatsApp, like there are a lot of images that will be getting transferred, PDFs, audio files, video files. This is all not like structured data. It is unstructured data. Okay, basically, if you can physically make out some meaningful information out of it, right? They'll that we call it. I mean, simple terms like structured data, say CSV file, Excel file. So that is all like structured data. You can load it into a table. And semi-structured data is kind of JSON. We'll be discussing those things in detail. What are the types of data? In a sense, variety of data. Okay, you no need to worry. But if you take right now, earlier it was all like maybe most of the data was structured data. Now, if you take even unstructured data is growing very fast. That is, say, audio files, video files, images, PDFs, all these things, right? So in order to handle that data, so usually relational database like will have you will be able to store unstructured data, but it is limited in the sense it is not that flexible to store basically semi-structured data and unstructured data. Only structured data, it is preferred to store it in relational database like SQL Server, Oracle. Okay, that way. So that's when uh, mm, I mean, like Hadoop came up. Okay, Hadoop or big data. Okay, let me show that. So here, with respect to this particular relational database, right? It is shared disk architecture. That is why it is shared disk is you are storing all your data in one disk. Okay, and then like here the way you are accessing data, right? I mean, even the server capacity is like only one thing. Okay, so this is basically shared disk architecture. So I'll explain you what is shared nothing architecture as well. So Snowflake is combination of, that is hybrid of shared disk and shared nothing. Okay, let me come up here. Here, with respect to this, um, I mean, if you have to increase the capacity of this particular relational database, right, you can do it vertically, in the sense, vertical scaling. Let me show you. There are two types of scaling: horizontal scaling and vertical scaling. So why I'm explaining this is you will correlate this thing with Snowflake architecture. Okay, that is compute all these things. That's why we are trying to show now itself. Here, if you see, you can vertically scale this particular relational database. That is, you'll be able to add resources, say RAM cap. I mean, increase your processor. Capacity, RAM size, and then hard disk. All these things for one mission, within one mission. Host is nothing but single mission. Okay, where you have installed your that particular relational database. So you'll be able to add resources vertically, in the sense, increase the size of hard disk, RAM, memory, all these things. Okay, but you can't make a cluster of missions. That is, you can't create a cluster of missions this way. That is horizontal scaling. You can't create a group of missions and connect them together with relational database. So in relational database, everything will be in one mission, one single mission. You can't create a group of missions and connect them together. Okay, that is not possible with relational database. That is horizontal scaling. Okay, give me a second. Now, if you see, um, like vertical scaling can be done for relational databases. That is, one big mission will do all your work, all the work for you. Okay, one big mission. Okay, horizontal scaling is nothing but thousands of missions will do work together for you. That is a group of missions. So a group of missions, like with respect to relational databases, you can't follow this horizontal scaling. Okay, it is only one mission. That is one thing you have to understand. That's when, and if you see the limitations of this relational database, like scalability is nothing but increasing the size. Okay, increasing the capacity, or so you can, if you have to increase the capacity of one single mission, there is limitation. You can't go beyond certain limit, right? But if you create a group of clusters and distribute your load, that is whatever you are trying to insert the data or read the data, right? If you distribute to multiple missions, say you can think of simply, if you have to say, I mean, all the work one person, if he has to do, how much work he will be able to do. If you take a group of a team, a team of, I mean, in a team there will be a group of members, right? If you distribute the work across multiple people, it'll get completed fast, right? Usually, if it is assigned to a single person, right? That time, how to certain limit he'll be able to do. So he has only 24 hours time, right? So within 24 hours, how much work he'll be able to do, you can correlate that way. Here relational database, it is only one mission, okay, only one person kind of, that is, you can't distribute work for group of people, in case of, I mean, if you have to simply correlate, okay. So that's when, that is scalability is nothing but you can't distribute, you can say, okay. That is increasing the capacity. So if you can't scale it, what issues you will get? Performance issues, okay. If a lot of users are trying to access your server at one time, that one particular mission, how many users it will try to serve, okay. That is, most of the queries will be waiting in queue, okay. And sometimes even server crashes if many users try to access, because of deadlocks, all these things, blockings, okay. Each user will block the other user's queries. You don't need to worry about all those things. We'll explain in detail what is blocking, all these things, okay. That's
Hitesh, I have one doubt.
yeah, yeah.
Even our DBMS database is also supporting the clusters, right? Means
Mm-hmm.
clusters. It will support clusters, right? It means like horizontal scaling means it will maintain the different data into the different servers, kind of things, or
No,
how it
no,
is.
no, that's fine. But one single database, I'm saying, not different databases. I mean, okay, one server, that is one single database. You can't distribute to multiple servers, right? I mean,
Uh,
multiple missions.
but cluster, by using the clusters we can maintain we can maintain, right, in our DBMS also.
We'll take this question in the end,
Okay.
Suresh. Okay.
Okay. Okay. Okay. Fine. No problem.
Yeah. Basically, I mean, it will be single server only, right? Like, okay, we'll take this question in the end. Probably, we'll see the other things like scalability. I mean, what issues, other issues you'll face. Okay. So here, with respect to limitations, right? Performance and speed, and then licensing cost. So here, with respect to SQL Server, uh, like you will. I mean, you will have to, if you have to install SQL Server or Oracle, right? First, you will have to buy license, and then maintenance overload. So you'll have to maintain indexes, partitioning, all these things. Okay. And then concurrency issues. That is, you'll face issues like can't handle large number of users at single point of time. That is, if many users try to access the data, you'll face a performance. I mean, they'll be waiting in queue. They'll face issues. Okay. That is one thing. And limited support for semi-structured and unstructured data, that is, say, images, PDFs, all those things, right? It will be, I mean, it might support, but mm, like it will be, I mean, not 100% flexible to this semi-structured, unstructured data. There is workaround sort of things, but you can't store huge volumes of things, and it is not that much flexible. And database failovers and upgradation costs. Sometimes, see, if you install one version of relational database, right, over a period of time, they will try to like upgrade that particular software. Say, if you take SQL Server, they will release updates, that is new versions every say, earlier most of them were using 2008 R2, now 2012, 15, 17, 19, that way every 2 years they're trying to release a new version. That time, if you have to upgrade your server, and some data types, if they're not compatible, so you'll have to take care of all those things, maintenance, upgradation, all those things, right? So this is also, these are some of the limitations of relational database. Okay. And then if you take big data, that's when, like, since relational databases were not able to handle huge volumes of data, okay, that is big data. That's when that's when like big data came up. Like, if you see like 5 years back, big data was a buzz in a sense. There was a lot of I mean boom on big data. But if you check now, like a lot of big data projects didn't click. The reason is there were flaws in Hadoop architecture. In a sense, this Hadoop, Hadoop came up in order to deal with this big data. That is, three V's we call, right? That is volume of data, variety of data, that is speed of change, and then the data sources, variety. That is, as I said, unstructured data, structured, semi-structured. That is, earlier it was all structured data. Now you are receiving more unstructured data, like images, videos, audio files, all these things, right? That way. Okay. So what is Hadoop architecture in simple terms is, that is, you don't need to this is all a background of why you have to go with Snowflake architecture. Okay. So that's why we are giving all this info that is there. If you take simply, this particular relational database base architecture is shared disk architecture. Okay. Whereas this particular big data or Hadoop architecture is like shared nothing architecture. Here, basically, if you take Hadoop architecture, let me explain. Here, in simple terms, if you have to explain Hadoop architecture, it will have master node and slave nodes. Okay, master node will manage, or coordinate all the slave nodes. So in slave node, you will be storing the data, and even processing will happen here. Okay, it will store data and it will process the data also. In a sense, say how it will. So if you are trying to insert some data into like Hadoop HDFS, so it will use. See here in Hadoop architecture, there are two layers. One is map reduce for processing or computation or compute. Okay, that is in order to run your queries or in order to process or your queries, it will use map reduce. Okay, see, it is not required for you. I'm just explaining, giving an overview or background of why you have to go with Snowflake. Okay, Hadoop itself is a big concept. If you take it will take 2-3 months to learn Hadoop. We are trying to give an overview on architecture. Okay, so here it will have two layers. Map reduce is for compute, and for storage we'll have Hadoop distributed file system, HDFS. Okay, that is as a storage layer. And now if you try to insert any data into this particular Hadoop architecture, right, what it will do is, first it will go to master node. In the sense, master node will decide and split the data into like 64 MB or 128 MB blocks, files. Okay, files. That is, if you are trying to insert, say, 1 GB of data, so it will split all the data into 64 MB or 128 MB blocks based on the version of Hadoop that you are using. Okay, so mostly now it will be 128 MB. So this master node will manage all the data distribution. So it will split it and try to distribute all the data into slave nodes. Okay, so that information, that is say you are trying to insert some data, right, 1 GB of data. So that is split into like 128 MB files and distributed across multiple slave nodes. Okay, this is master node and slave node. This so all the data will be stored. That is, that 1 GB of data will not be there in one machine. Okay, one slave node. It will be distributed across multiple slave nodes as 128 MB files. So it will be split into that and stored across, distributed across multiple slave nodes. Okay, here if you try to run your query, right, so with some calculations, aggregations, whatever you are doing, so it will use this map reduce in order to get that data. Okay, in order to retrieve that data. So in this case, that particular compute will happen in slave node only. Okay, slave node only. But where here, since it is distributing the data, right, and even compute is also distributed. For large volumes of data, you might get some performance improvement. Here also you have flaws. The reason is, say you wanted to combine the data. So now all the data is distributed, right? All the data is distributed. So when you try to run query, so it has to get data from multiple missions. So so since data is distributed across multiple missions, in order to combine, it will take time. Okay, that is internally they were how this map reduce works is, it will use shuffling, sorting, all these things. That is, say you have data distributed in multiple slave nodes. So if you want to get, say, this output, so it has to search, it has to combine, in simple terms, it has to combine data from all these nodes and give you the result, right? This will take time. Okay, this will take time. Okay, here if you see, this is the process that it follows. So it is not required for you. I'm just explaining on high level. Since here the main thing is, since data is distributed, right? Data is distributed across multiple machines. Um, in order to combine data, it will take time and you will face issues. What disadvantages of this Hadoop is, even data is distributed here. Okay, so if you have to combine the data, it will take a lot of time. That is one major drawback here with this Hadoop architecture. This particular architecture, we call it shared nothing architecture. Okay, this particular big data or Hadoop architecture, we call it shared nothing architecture. Data and compute will be done at each slave node level. Shared nothing architecture. Okay, so here, since data is distributed, you will face performance issues. These are the disadvantages. It is not suitable for small and real-time data applications, and joining multiple data sets are complex. Or that is, if you have to combine data, it will be very complex because all the data is distributed, right? That's why. So, and cluster management, all these things, and even some issues with respect to here. If you take earlier, initially when they came up with this architecture, like there was only support for only one master node. Okay, one master node, like it has to take care of all these things. So it'll store, see, this master node will coordinate all the slave nodes, and then, see, whatever data you are trying to insert, right, that information, that is, say, this particular slave node has what data it is there, and then that is, we are distributing, right, which file or which block is there in which slave node. All that information about the files or data will be stored in this master node, and it will try to, when you run your query will go to master node, and master node will decide where it has to get data from. So, and then it will try to, even in case of, say, any one slave node fails, right, that is, if the slave node is down, here basically the file is replicated, that is, will be available in 3 nodes. Okay, so that way, in case of failover, like master node will take care of all those things. Okay, so this is bit complicated process for master node to take care of all these things, and these were the disadvantages. The main drawback with this Hadoop architecture, or the flaw in Hadoop architecture, is even data is distributed, right? That's when, in order to combine data, it will take time and it will be slow. Your queries will become slow. Okay, performance issues you will face with Hadoop if you want to join multiple data sets, all these things. Okay, that's one
So
thing you have
it's
to keep. Yeah.
uh, Hitesh, it's not replication, right? It's just data has been shared,
Where?
splitted among the slaves, right?
No. Even, say, I told you it will split the data into 128 MB blocks, right?
Yeah.
So
Okay.
what it will do is, it will store that file, 128 MB file or block, in 3 machines. Okay,
Okay.
that is,
Okay.
in order to, suppose one slave node failed. In that case, you will lose that data, right?
Yeah.
So in order to avoid that failover, like it'll replicate the data.
Okay.
Yeah.
Replicator.
Yeah. Replicate in the sense it will maintain 3 copies.
3 copies. Yeah. Three
Yeah,
copies.
usually that's how it works. This is,
Okay.
usually it is a big concept. So
Yeah.
within 1 hour or half an hour, we can't cover all these things. Few people will get confused.
Yeah.
That's
Yeah.
why
The
I'm trying to
basic.
cover it on
Yeah.
high level. Yeah.
Yeah. The basic knowledge is important. That's more than enough for us, actually.
Yeah. So here you don't need to understand the Hadoop architecture in detail. You'll have to just know what advantage we get with Snowflake architecture. That's it, right?
Mhm.
Compared to Hadoop or relational database. Okay.
Okay. Yeah.
Hmm.
Got it. Thanks.
Okay. Now the main advantage with Snowflake architecture is, here Snowflake architecture, it takes the positive points from both relational database and Hadoop architecture. Here, if you take Hadoop, yeah, someone has any doubt? No.
Okay, we'll take all the questions in the end. Okay. Now I hope like you got some fair idea of what are the flaws in or disadvantages or limitations with respect to relational database and big data. So here Snowflake architecture, like it came up with unique. I mean, how I think. Let me mute. Give me a second. I'll mute everyone. I think there is some disturbance. Okay. Now, here with respect to Snowflake architecture, right? It takes the positive points from both relational database architecture and Hadoop architecture. So what it does is, so in order to store data, it will use shared disk sort of architecture. I mean, it will take the positive point of shared disk. That is, all your data will be stored in at one place. That is centralized data store. Your data is not going to get distributed. Okay, your data you're not going to distribute, like in case of slave nodes you are distributing the data, right? It won't happen here. It is centralized data store in case of Snowflake architecture, but your processing or compute will be distributed like shared nothing. Okay, you got it, right? That's the advantage with Snowflake architecture. How they are maintaining this I mean this way, that is centralized storage and then distributing your compute or query processing is, I'll show you. So this particular Snowflake architecture, it is hybrid of, that is it takes you know, right, what is hybrid? It is hybrid of shared disk and shared nothing architecture. What is shared disk? Relational database. That is, this is shared disk is nothing but relational database architecture. Shared nothing is Hadoop architecture. Okay, so it combines both the things, I mean, and take the positive points from both the architectures and came up with one hybrid architecture. Okay, so this is unique, innovative Snowflake architecture. What we call that as, let me show you. So see, many people are not aware of this thing, that is hybrid of shared disk and shared nothing. Okay, usually they call it, Snowflake says this particular architecture as multi-cluster shared data architecture. Let me show you here multi-cluster shared data architecture. Okay, I'll explain you why they'll call it multi-cluster. You know, like shared data, right? This is kind of shared disk. That is, all your data will be stored in cloud. Okay, cloud in columnar format, hybrid columnar format. We'll discuss, I mean, how the data will be stored in Snowflake, all the things in detail. That time you will get to know what is how it stores data in hybrid columnar format. Okay, in cloud. Basically, all the data will be stored in cloud. Okay, so it is not distributed. It is kind of centralized storage. Okay, shared disk, like relational database. But processing it will be distributed. It is distributed with this query processing or virtual warehouses. We'll see what is virtual warehouse, query processing, all these things. This particular architecture, say if you're appearing for Snowpro certification, right? This question they'll ask, what is Snowflake architecture? It is multi-cluster shared data architecture. Okay, in interview point of view, right? If you explain, say they'll ask you, why should you go with Snowflake? Okay, what is the reason that you'll have to go for Snowflake? So you would have already, since most of them are from that is interviewers who will take your interview, right? They are from SQL or database background. So they'll ask you this question. So why you might be using relational database, right? Why you have to go with Snowflake? What advantage you get with Snowflake in terms of architecture? If they ask that, like you can say this is Snowflake is hybrid of shared disk and shared nothing. Like shared disk architecture, it maintains centralized data repository. Okay, that is, all your data is located at one place. It is not distributed like in case of Hadoop. Okay, that is one that is similar to shared disk. It stores data for storage. Basically, it will use share, like relational database kind of architecture. For compute or query processing, right? It use shared nothing. That is, it distribute your query processing. Okay, let me, yeah, those points are highlighted here. Data is stored in cloud storage and works as shared disk model. thereby providing simplicity in data management. If all your data is at one place, the data management will be simple, right? If it is distributed, even data management also will be complicated. Okay, so that is one point with respect to data storage. And for compute, it will take advantage of performance and scale out. What is scale out? I'll explain you. Okay, benefits of shared nothing architecture. Okay, that is like shared nothing or Hadoop architecture. It will distribute your query processing. Is it clear? I mean, this is important, guys. I mean, if you understand this concept, right? I mean, if you explain in interview, if they ask you what is, I mean, why you have to go with Snowflake architecture, you'd be using relational database or Hadoop, right? Why you have to go with Snowflake architecture? How it is different? If something, for sure they'll ask this question, especially for experienced folks. Okay. So that time, if we explain that in detail, that itself will throw positive impression. Okay, if we explain this clearly. Here I will see like the other things as well. And this approach offers a data management simplicity of shared disk architecture, and along with that you will get performance and scale out benefits of shared nothing architecture. Okay, and let me show here. Here in with respect to Snowflake architecture, right, it has three layers. Okay, it has three layers. One is storage layer, and then the second layer is query processing, third layer is cloud services. So if you see, all your data will be stored in cloud. Okay, so when tomorrow we'll see how we can create a Snowflake account, and at that time you will get to know like how data, what are the different things. That is, I'm saying cloud, right? It is available on all clouds. Snowflake is available on all clouds. So you will get to know how it is. If someone is not aware, if someone is already aware, that's fine. But whoever is not aware, you will get to know why we are saying Snowflake is available on all clouds, and it supports multi-cloud, cloud agnostic, all those things. Okay, so whichever, while creating Snowflake account, you'll get option to select AWS, Azure, or Google Cloud. That is, you can host your Snowflake account, that is Snowflake account, in any of these clouds depending on client. Okay, so if you select say AWS, all your data in the backend, it will be stored in AWS S3. Okay, this is, see here, you will not have any control, in the sense like you will just select the cloud provider and then the region where you will have, I mean, Snowflake has to store data, but all the management, data storage, organization, everything will be taken care by Snowflake only. Since Snowflake is a software as a service, so it will take care of all those things. Even we'll see the cloud basic cloud computing things also. What is software as a service, infrastructure as a service, all those things. Okay. And then for query processing or compute, that is, if you run any queries, right, it will be executed through virtual warehouses. So many people will get confused here with respect to Snowflake, right? Two things are confusing, and based on the naming, like Snowflake has named, right? So one is the name itself, Snowflake. So many people who are already working, right, they'll get confused with this name Snowflake with the way you design a data warehouse. Like you can design it in star schema and Snowflake schema, right? So many people will get confused with that terminology, but it is nowhere related with that Snowflake schema. Okay, Snowflake is a cloud data warehouse here, and then this virtual warehouse, people will get confused with like data warehouse. Okay, it is not data warehouse, it is cluster of compute missions. I'll show you that. Virtual warehouse, here we'll use virtual warehouse for query processing or compute. That is, if you have to run any query, or if you want to insert some data, if you want to run a select statement, you will use virtual warehouse for compute. Okay, this is virtual warehouse. Here is nothing but cluster of compute machines or nodes. Node is nothing but machine. That is, you know what is a machine, right? So it is a group of machines. Cluster is nothing but group. A group of compute machines or nodes. You call it virtual warehouse. Okay, here. So we'll use this virtual warehouse for computation, that is query processing. Okay, so this is second layer. Okay, this is kind of muzzle of the system. Here we can perform massive parallel processing. Okay, we'll be discussing each and every layer in detail. We'll be doing a deep dive. Here, the main advantage with Snowflake architecture is here if you take shared disk, right, all your data and processing will happen in one mission. Okay, one mission. Both storage and compute are coupled together. The main, if they ask you the main difference, this is the main difference with respect to here. Storage is a separate layer, okay, and compute is a separate layer. This is the main advantage for Snowflake architecture. Okay, so you can store as much data as you want. Since it is in cloud, there is no limit in terms of storage. You can scale is nothing but increase, add capacity, something like that, right? There is no limit as such. Based on your usage, you can add as much as data you want. Okay, because storage is in cloud and it is a separate layer. It is not nowhere related with compute. Okay, so that is query processing. Here, how the query processing will happen is it is in a separate layer. Okay, it is not tied together or coupled like shared disk architecture. Sorry, like relational database. Okay, that's one primary advantage with the virtual warehouse. That is independent storage layer and query processing layer. Okay, if they ask you what is the main difference between relational database and Snowflake architecture, is first thing is decoupled architecture. That is, storage is separate and compute is separate, or query processing is separate. Okay, and then there is a third layer, cloud services. Cloud services is kind of brain of this particular Snowflake architecture. Okay, so it coordinates between the compute and storage, and then it manages infrastructure, that is where it is storing the data and what data is stored in cloud. So the way it stores data in Snowflake is in micro partitions, columnar format. We will discuss that in detail in our later sessions. So all that thing will be managed by this cloud services. So that's why we call it brain of this particular Snowflake architecture. So, and then access related things. Suppose a user tries to log in and wanted to see, that particular access control or management will also be taken care by this cloud service layer. And then security, security related things. And as I said, metadata is nothing but, so say you are creating a table, it will have a list of columns, data types that you will specify, right? So those things, that metadata information will be stored in cloud service layer. Okay, and then query optimization, even query optimization, all these things will be taken care by this particular this particular cloud service layer. Okay, any confusion, guys? Like, is it clear what advantage you get with this particular architecture with compared to say relational database or this particular Hadoop architecture? Is it clear, or any confusion?
Yeah, it's clear. Hitesh. What about the background process? That also comes under the cloud services.
Yes. See, here, since Snowflake is software service, most of the things, as I said, say if you take relational database, Oracle or SQL Server, so DBS will take backup of data, and index maintenance, partitioning, all these things are managed by them. But here, in case of Snowflake, all those things are managed by Snowflake itself. Most of the things are taken care using cloud service layer. That's why we call it as brain of the system. Okay, we'll be discussing each and every layer in detail.
Okay.
Then you'll get to know. Within 1 hour, half an hour, it will be difficult to understand all the things. So we'll be doing a deep dive on each and every thing. Here, the main thing, even see in terms of cost also, like how Snowflake charges for this storage. Storage it will cost separately. That is based on how much volume you are storing, volume you are using, right, or storing your data. So based on that, per TB, on average, for 1 month, if you are storing say 1 TB of data, it will charge $23 on average. Okay, so for the entire month, if you on average, if you are storing 1 TB of data, it will charge $23. So that also will slightly vary based on some few things. But if you can take an average, that is how it charges. It is very minimal. Okay, it is very minimal if you storage costs. Basically, Snowflake won't keep any margin with respect to storage. How much ever this cloud provider, say you are using AWS, right? How AWS charges for storage, the same way it will follow. Okay, most of the things they won't keep much margin with respect to storage. They are making revenue, that is Snowflake is making profit with respect to compute. Okay, how you'll use this query processing or virtual warehouses. Here, as I said, there are different sizes of virtual warehouses. Okay, we'll discuss this query processing is keeping here, that is compute using virtual warehouses. Okay, and as I said, storage costs are different and compute costs are different, in the sense they are not charged together. Okay, how much ever volume of data you store in Snowflake, you will be charged for that with respect to storage. And for query processing, it is based on per second basis. Okay, that is, it will charge uh, uh, minimum for 1 minute, and after that it will be per second basis. That is based on this virtual warehouse. So tomorrow we'll try to create a Snowflake account, and I'll try to show you how we'll create virtual warehouse. What are the different things I was saying you right in demo session, that whenever you are not using virtual warehouses, you are not going to pay. So that is, this Snowflake offers true pay as you go model. That is, if you are using compute, then only you will pay, or else no need to pay, that kind of thing. And the second billing is key thing. That is, it will charge compute based on per second basis. That is, if you have used for say 90 seconds, you will be charged only for 90 seconds, but minimum it will be 1 minute. Okay, this many people they'll get confused with this. And there were other things also with respect to pricing. We'll have a separate detailed session on pricing as well, how cloud services layer is charged. If you ask someone who is working on Snowflake, right, they'll not be able to answer. You can check. Okay, so but we'll be covering a detailed we'll have a detailed session on pricing as well. So what are the different considerations you'll have to select? You have to take how the pricing will vary, especially that will be helpful for senior folks. Okay, because pricing is a key thing, right? That's when clients will, if the cost is less, then only clients will use Snowflake. If it is heavy, like they won't use. If you take a lot of projects that are using Snowflake, they are migrating data from say SAP, Salesforce, and Teradata, all this thing. If you take especially SAP, the reason that they are coming to Snowflake is because of cost. Okay, Snowflake charges very less, and it is very economical kind of, if you compare with other things. Okay, so let's
Hitesh, one doubt, Hitesh.
yeah.
Hitesh, you're saying data is not distributed in Snowflake, right? And in
Yeah.
Hadoop, it is distributing like a block wise, right?
Mm-hmm.
If the unstructured data, it will be stored in a Snowflake, like any videos, or it's a big videos, and whether it will occupy more space in cloud level, because
No.
data is not
Yeah.
distributed and it will
Yes,
store in
I'll explain you. So here, apart from these things, there is one more advantage with Snowflake. Okay, whatever data you are trying to load it into Snowflake, right? All your data will be compressed. Okay, that is, Snowflake itself will compress the data. Say you are trying to insert a file with size 1 TB, it will compress that first. Snowflake will do that. We are not going to do it. In the back end, as soon as you try to load something, right, Snowflake will compress that data. That is one main advantage. And you will be paying, say, for storage, right? Say you are trying to load from outside a 1 TB file. It will compress that file first. Snowflake will compress that, and you will be charged only for that compressed data. Say after compression, it has gone to 500 GB. 1 TB file has gone to 500 GB. You are going to pay only for that 500 GB. Okay, that is one main thing. And even all your data will get encrypted. Okay, as soon as you try to load data, it will compress that data and encryption. So if someone is not aware about encryption, who are from non-SQL background and data background, it is with respect to security. Since that we are storing all the data in cloud, Snowflake will in order to take advantage, security is also a key concern, right? That's why, like, they will encrypt the data as well. As soon as you try to load some data, even files, like, it will compress that file and encrypt that data. Okay, all the data that whatever you try to push, it will get compressed and encrypted. That is taken care by Snowflake itself. We are not going to do anything.
Okay.
Okay.
It's a default behavior of Snowflake, I mean compression
Correct.
and
Correct. Yes. Yes. So these are other advantages that with respect to Snowflake. Okay. And see, if the data is compressed, right? If the data is compressed, you can think of even your compute time will go down, right? If based on data volume, basically, if you are trying to extract, say, 1 TB of data, it will the compute resources also. If you're compressing, it will take lesser. I mean, say, if it is 1 TB of data, if you try to query, it might take, say, 15-20 minutes. If it is compressed to say 500 GB, even your query runtime also will go down, right? That way, that's why I mean, you'll face, if say, without performing anything, say you are storing some data in Oracle or SQL Server, if you just migrate that data into Snowflake, you will get a lot of performance benefit. You can observe that, okay, without doing anything, if you just migrate the data. And even the way it stores data is a unique, different way, hybrid columnar storage. When you understand that, you'll get to know. As I said, in Snowflake, there is nothing like index maintenance and then partitioning, all those things. We are not going to do that. Everything will be taken care by Snowflake only. Okay, so that way clients will save even this what you call administration work. Say they'll maintain a DBA team where they'll be taking backup of data and then creating partitions, maintaining indexes, all these things. Even performance tuning, most of the things will be taken care by Snowflake itself. Okay, we'll have very less control with respect to performance tuning. So most of the times performance also, I mean, you won't face any performance issues as such, but there were few things that we have something in control, which you can do it with respect to performance tuning. So all those things also will be covered as a part of our training. Okay, I think it's already 8:50. Probably we'll discuss in detail on these layers. What is you would have got like a fair idea of what is Snowflake architecture, what advantage you get, what are the different layers, and then already that day I told you we discussed this thing. There are different virtual warehouse sizes. That is compute layer. You have, say, um, different sizes. Say extra small will have 1 compute node, small will have 2 compute node, medium will have 4. That way, if you take 4XL, it'll have 128 compute nodes. So you can think of, like, if you compare with relational database, one mission, if it is able to perform or serve like those many users, how many users this particular 4XL virtual warehouse will serve, right? So that way, and even as I said, you can set it to auto scale mode, and then like it'll add 10 clusters. Up to 10 clusters will be on demand. It'll try to add. So I'll show you tomorrow. We'll try to create a Snowflake account, and I'll try to show you all these things, how virtual warehouse works, what are the different things that you will have to do with respect to virtual warehouse. Okay, that time you'll get a clear picture of what I am saying, how advantage it is. I was saying up to 1028, so 1280 nodes you can scale. That is, you can distribute your workload across those many missions, right? How that can be done. Okay, any questions? I think probably now we can take the queries.
Yes, Vidya here. I have a question.
Yeah, Vidya. Yeah.
Yeah. See, yesterday we discussed about the dataware architecture, right?
Yeah.
We have staging and data mart.
Mm-hmm.
Yeah, even in a cloud data warehouse, do we need to have those 2 layers?
Okay, so that's this is also kind of database only. That is up to us.
Dataware.
Like, it's depending on client needs. You can maintain, if they want staging layer, they can maintain that, or directly they can maintain a data warehouse.
Okay.
This is also kind of another database. Okay, you can design a data warehouse or data vault also. You know data vault, right?
Huh.
So as per client needs, they will. I mean, they can they can redesign and they can go with their model, whichever most of the times they'll use data warehouse. They'll migrate the existing data warehouse as is into Snowflake.
Client needs you said, right? Are there any specific needs like which we can go for them? I think it will
Basically,
be a big thing, to explain. Okay.
yeah. I mean, you will get to know, like as you said,
Yeah,
like
yeah, I see.
how the data will get loaded, staging layer. Usually, most of the times we'll maintain staging layer as well
Yeah.
in Snowflake. Okay, before
Okay.
loading that into actual data warehouse. The
Okay.
reason is, yeah, we have few features like streams. I was saying, right? If you have to say maintain SED type 1 or type 2 historical data in Snowflake, right? That time you will create streams on top of the staging tables. Okay, so I mean others might get confused if they are not
Okay,
from
okay,
there.
okay, okay.
So when that
When time comes, okay, we'll get to know.
correct
Yeah.
in that
Yes,
session
sir.
when we discuss about the data loading, all those things, at that time we will get to know. Yeah.
Yeah, sure. Thanks.
Hitesh, can you please, you mentioned compute, I mean, regarding this compute, you mentioned RAM, CPU, and memory on the page 4 or
Yeah.
3. What exactly? Actually, usually in generally talking, I mean, RAM is actually a memory, but
Correct.
you have
There will
mentioned,
be, like SSD, right? SSD. Right
yes,
now,
yes,
it is hard disk is there, SSD is there.
solid
Hard
state.
disk, if it has to get data from hard disk, it will be slow. If it is in SSD, it will be very fast. You'll have both the options, right? If you
Okay,
take
yes.
memory, SSD is what I mean to say. Okay,
Okay,
I'll be
yes.
explaining that. There are different types of caches as well. Okay,
Okay.
so when we discuss that time, you will get to know that part. Yeah,
Okay,
that's a
along
good
with,
clarification.
yeah, along with the RAM and CPU, we have to say memory also.
Yeah, memory in the sense that is SSD cache. What I mean to say.
Okay, SSD cache. Okay, got it. Thank you.
Yeah,
Hitesh,
Hitesh.
Vinita here.
Hey, hi Vinita.
Sorry,
Yeah.
please go ahead.
Yeah, you
So
can.
I just
Anyone
wanted
can
to go
ask.
back. Okay, I just wanted to go back to the question. Someone has asked about the cluster and the nodes in the relational, in the traditional architecture we have, like with RDBMS. So usually the traditional architecture is we do have one cluster and multiple nodes over there. And with availability groups and all, we just, sync the data. Only one node will be active, primary node will be active, but the data is always, shared across the other nodes. And during the failover, that's how we maintain, right? That's how it is maintained.
But data you are not going to distribute, right? I got to know, but there you are not distributing your data, right, across multiple missions. It will be there in only one mission, right?
No,
Yes,
when we
in
have
Oracle,
the
yes.
availability. Sorry.
Yeah, in Oracle, that's what Hitesh said. There'll be as data will be in one place, but it'll be shared across the nodes.
Yes, same in in SQL Server, what happens is, when we have the availability groups and whatever the databases we want, if we include it, so it will be shared across all the nodes.
You
So
mean
when
the
during the
data? I
failover,
wanted to understand one thing. Say you are creating a table, okay, and
yeah,
say
yes,
it has got. I mean, that table has got 1 TB of data. Will that 1
yes.
TB file that say it? I know in SQL Server it store MDF and LDF files, right? So will that
Right.
MDF file will be distributed across multiple missions?
Hitesh,
The
Hitesh,
file storage.
yeah, Hitesh, I will say one thing. See, we will maintain the database. Okay, for example, we create one database and we will maintain the same database into multiple nodes. Okay, same data, same database. Okay,
Yeah.
that will
Yeah.
happening. We are not distributing any particular data. In one node, it should be in some data, and another it will date in another. We are not doing that thing. Okay, we will maintain the one same copy of the server into different nodes.
That is replication. That is replication, right? Like that is not like distributing the data. I got to know
Yeah,
what you are
correct,
saying. What
correct,
you mean to
correct.
say that is in case of failover, it'll there will
Yes,
be two nodes, primary node and secondary node. So in case of
correct.
primary node failure, it will switch to secondary node. That is a different thing. That is not
But
the distribution, right?
when
That is
comes
not
to the
replication
snow,
as well.
Okay.
Because replication happens over the server, and a server,
This
and
is the
the
new
data
feature, right?
centers
Earlier it was not there.
actually.
Maybe after 2012
Yes,
2012 SQL Server onwards, like we have
yes.
this option, right? I'll discuss
Yes,
with you guys separately.
2017 has
Yeah,
availability
17.
groups, but
Yeah.
the replication happens over the data centers, and the data
I'll explore
center
that and I'll
once.
get back to you tomorrow. Like I
Thank you,
for
Hitesh.
sure I believe like data won't get distributed. It'll be
It means,
centralized.
yeah,
It,
it means data distributing means, for example, we have the 1,000 records will be there. Okay,
See,
so
I
we are
told you
meant,
right here.
yeah,
One second. So
yeah,
now, in case of Hadoop, what I said, like your data is splitting, and then it will be stored in multiple slave nodes, right? That way, it won't happen in SQL Server, right?
correct.
Hmm.
That is true. Yeah, it means,
I think,
see, I have,
as
Mhm.
I will say one scenario, like for example, we have 1,000 records will be there, 1 to 1,000. Okay, so we will
Mhm.
maintain each like 1 to 100 one in one slave node, and 100 to 200 in the one another slave node, like this
Mhm.
distribution, right?
Yeah.
Correct. Okay, so in SQL we cannot able to do in the, like when compare when we do the into the like multiple nodes, we will maintain the same copy. That's it. Like a high availability and disaster recovery, we will use for that one. Same server. Yeah.
Yeah, Vinita and Suresh, I'll check that option and I'll let you know. I'll clear that up tomorrow. But
yes, I will
as far
also
as my
verify.
knowledge, like, I think it is like there. Yeah, cluster might be there, but it is for failover, I believe. Like whenever there is
Yes,
a primary
Correct.
node fails, like it will switch to secondary node. It will make that
right.
node secondary node as primary. That is different,
Yes.
Vinita. Yeah, I'll,
Okay.
I'll
So, and
explore.
I think there will be
I know
common
that
files
concept
and
as well, but that is different from what
mhm.
Snowflake. What we are doing with Snowflake.
Okay.
Yeah,
Okay, I
clustering.
see. Because
Hmm.
the data where the second layer, apart from the
Mhm.
storage and the query processing, which you had
Mhm.
shown in the slide, I
Mhm.
see that the virtual data warehouses. So virtual data
Correct.
warehouses is something related to, is it something similar to clusters? Are we going to have
Correct.
different data? Okay,
Cluster is nothing but there it is a group of machines. And
group of
I'll,
machines, and
yeah,
okay,
mm,
and these are hosted on cloud. Are
correct.
these hosted on
That's
cloud?
true.
Okay,
In the back end,
go.
see, I'll explain you that in detail. Many people are not aware of those things. That is
Okay,
how.
no problem.
Yeah, tomorrow you'll get to know in a clear picture of what you are saying. I'll also this particular SQL Server 2017 clustering you are saying, right? That also I'll explore and I'll give you a complete picture of what
Yeah. Even
how it is.
maybe I might be wrong too. I will also do my research and I'll get back to you. And I strongly feel that there will be files and everything shared at one location, and all these nodes have
It'll be
access to
stored in
those
one location
files.
or in one machine.
Yes,
As
yes,
far as my
yes.
knowledge, it is that particular concept which you are saying, right? That is in order to
Right,
handle failover. Even in our project, we used that kind of scenario. Okay, that's why
right.
I'm confidently saying I'll explore that and I'll let you know. Okay.
Yes, no problem, Hitesh. So one more clarification I wanted
Mhm.
is, I just wanted to just understand and distinguish the architecture. So what I am hearing right now is like whatever the architecture we have for SQL, like
Mhm.
the cluster nodes and all. Now we have all this in on-premises servers and all. So when we
Mhm.
go to Snowflake or the cloud services, all these are hosted on cloud, and we are making this scalable as much as possible, right?
Correct. Yeah,
So
that's true.
on a higher point of view, I just wanted to clarify if I am on the right way or not.
Yeah, that's true. That's true. Like see, all
Okay.
these things are possible because of cloud. So Snowflake, it is not available on premises. Okay, it is
Yeah.
completely built from
Yes.
scratch on cloud. That's why they took
Yes.
advantage of cloud and they came up with unique architecture.
Okay. And the clustering, the
See,
concept of the clustering and everything remains same. The only thing is it is on the cloud.
clustering. Okay,
Can I
that
say
that
that?
is no. I think SQL Server clustering is different from Snowflake clustering for sure. Okay, how it behaves.
Okay.
Okay, I'll
Okay.
explain you.
Okay.
Yeah, you'll get to know.
Okay. Thank you,
So if it
Hitesh.
is the
That's all I have.
same case, then
Mhm.
everyone will use SQL Server in cloud, right? Why they'll have to go
Yes.
with Snowflake?
Yes. There could be some features could be different, but the
No.
concept of
The clustering with respect to SQL Server and Snowflake is completely different. Okay,
completely
I'll
different.
explain you that
Okay.
tomorrow.
Okay. Okay, Hitesh. Thank you.
Mhm. Fine. Yeah. Any other questions, guys?
Yeah, Hitesh. So it is like as I got to know, like Snowflake, it is shared nothing, right? Means
No, it is hybrid of shared disk and shared nothing. That is not shared nothing is Hadoop architecture, right?
okay, okay,
It is
okay. You mean
hybrid
to
of shared
say
disk
like,
and shared nothing. We call it multi-cluster shared data architecture. I mean, if you take certification, right, they won't give you hybrid of shared disk, shared nothing. They'll give multi-cluster shared data architecture. I'll explain you what is multi-cluster shared data. You understand? You got to know, right? Like it is like kind of shared.
yeah.
Hmm.
For example, in single mission, it will be like a shared disk architect, right? It means like,
Mhm.
for example, SQL Server. Okay, it will be stay in the one
all the
server.
data all the data we are maintaining in at one place, centralized data store, you can say. Okay, that particular
Okay,
concept we call it shared disk.
shared disk. What about Hadoop? Also, it's shared disk or?
No, it is shared nothing, right? There you are distributing your data as well as workload, right?
Okay, we are
Compute
distributing
and
this. Okay, okay, shared
across slave
nothing.
nodes, multiple slave nodes, right? That's where that's when yeah.
Okay, then what about Snowflake? Snowflake, like it's shared nothing means it is not depending, right? Means it is not like sharing kind things, right? It means
It
shared
is
nothing.
hybrid of both. That is, as I said, storage,
Mm.
it is centralized data store. Okay,
Okay,
and
okay,
compute it will get distributed like shared nothing, like a relational database. It will
mm.
store all the data at one place, centralized data repository. Okay, shared
Okay,
disk
okay,
kind of. But
okay.
for compute, it will get
It will be
distributed across multiple machines using
storage.
this virtual warehouses, um, like our Hadoop architecture, like shared nothing. So it is hybrid of both these things.
Okay, okay, okay.
Mm.
Hybrid of shared disk and
And shared
shared
nothing.
disk nothing. Okay,
Yeah, we
okay,
call that as multi-cluster shared data architecture.
okay, okay. Yeah, got
That is the terminology that Snowflake will use
it.
to uh, to convey that their architecture.
Okay, still I have like little confusion means a hybrid of this shared disk and shared nothing. That
Mm.
so why? Because like it will be like you mean to say like virtual warehouse are distributed and also storage also distributed, right? It
Storage
means
is not distributed. Storage is in at single place, right? In cloud,
okay, okay,
centralized
okay,
data repository. Mm.
okay. Only virtual warehouse are distributed,
Data,
correct?
yeah, compute. See, compute will get distributed. That is, if you run query, right?
Yeah,
Based
yeah.
on you'll get to know tomorrow, like what is virtual warehouse.
Mm,
Then you'll get some
mm.
fair idea. Yeah,
Yeah, yeah, fine, fine. Still confusion for now. So we can clear tomorrow. I think. Yeah. Thank you.
yeah, sure.
Thank you. Yeah.
Hello.
Uh,
Hi, Tej. Yogesh
yeah,
here.
okay. Yeah.
Uh, uh, you mean to say for the data sharing, it is like a shared storage, shared disk architecture, but the
Mm.
for queries, it is like a share nothing architecture, right?
Correct. That's true.
Okay.
That is, your compute, your query processing will get distributed like shared nothing. Okay. In order to say, if you distribute your workload, it will be
Means like
faster, right? Yeah,
means
it will
like
your queries will be faster.
one query
So
will not be shared with different machines.
yeah, your workload. Yes.
Okay. Okay. Got it.
Your query processing will get distributed. Your storage is centralized store in case of Snowflake. Okay. Yeah, if anyone has any questions, we can take, or else we can. I'll be there for some more time. Whoever has doubts, they can stay. Others can drop off. Thank you, guys.